Yeah, thanks for the nice introductory words, and also to the organizers for having me here and allowing me to present some recent results of research that I've been involved in. But it's not only research that I've been involved in, there's of course also a few other things here. So I will spend the next roughly 30 minutes talking a little bit more about the energy system transformation towards a sustainable future, looking at challenges and opportunities, and the 1.5 degree target was already mentioned several times in the introduction. And of course there was earlier today, let me see how this works. Okay. There was a presentation by Jan Fuglestvedt giving you a high-level overview of the 1.5 degree report, and I think you saw this slide essentially here. That's, by the way, the only Norwegian that you will unfortunately see in this presentation. I borrowed from Jan's slide deck the short descriptions of these illustrative pathways. And let me take a little bit of time to dive a little bit deeper into these pathways, to unpack also the underlying energy transformation associated with them, and maybe most notably to point out here, I will focus on two of the four pathways to keep it kind of manageable. One I would say is this the P3 pathway, which I would classify more as a conventional wisdom pathway from an IAM perspective, from an integrated assessment model perspective. These types of models are used to generate these outlooks, how the future might evolve, and what the energy system part is in reducing emissions. And there is another one that is called P1, or LED, low energy demand pathway, that is really looking at a much more consumer-centric approach of tackling the 1.5 degree target. And one key difference that almost pops into your eye when you look at this graph is in the one case you have this negative contribution here to the emissions that are shown here, labeled as BECCS, or bioenergy with carbon capture and storage, as a way of compensating emissions that are emitted in the more foreseeable future. And as probably many or all of you know, there is a very controversial debate about using this technology to compensate in the future for lack of ambition and action in the short term. And there are, of course, negative side effects associated, or potential negative side effects associated with deploying bioenergy with carbon capture and storage. And then on the other side, here on the left-hand side, this LED pathway, you see that lacks this yellow wedge, if you wish, and so doesn't rely on bioenergy with carbon capture and storage. But the trade-off then is that a lot more needs to happen in the short term. And that is really, that's the other criticism that is coming up, that it is felt to be unrealistic that very substantial emission cuts need to happen essentially over the coming decade or two. And I will try to give you a better sense of how large the challenge is, also from a more European perspective, because the global picture is actually more rosy, than what would need to happen in developed economies that have more capability of reducing emissions. This is the table that is underneath this graph. Don't worry, I won't go through these numbers in detail. Just want to pop out or highlight a few of them. Namely the 2030 action here in terms of reduction in Kyoto greenhouse gas emissions relative to 2010. In one case, that's a 50% cut. In the other case, it's a 35% cut. So these 15 additional percentage points you essentially buy by then later on deploying negative emissions technologies with all the problems that they have. And one of the vehicles to get these very very extreme emission reductions in this LED scenario is to particularly focus on demand-side measures. That will be a good chunk of my talk will be about empirical evidence that actually shows that that a transformation through the demand side might actually be much more can happen much more rapidly than a supply side focused transition. And here you see in one case we have a 15% reduction in final energy demand at the global scale by 2030 relative to 2010. In the other case, a 20% addition. And let me highlight already here, in both cases there's a substantial expansion in terms of energy service provision. So this is not supposed to happen at the cost of not providing services, which is a particular concern in developing countries that perceive mitigation often as something that is imposed on them and might hinder them in terms of economically developing. And then another point here is the renewable shares, which are higher in one case than in the other. And then I already highlighted the cumulative bioenergy carbon capture and storage is in one case 0 by construction, in the other case quite substantial, so 400 gigatons, roughly 10 times the current annual emissions would need to be sequestered over the courses of the century to compensate for the lack of short-term action in this more conventional scenario. Yeah, to just sketch it, so the more conventional type of scenarios assume a lot of inertia in policy, social and technological change. As a result, produce a relatively large overshoot in terms of also temperature as well as emission profiles, and then compensate in the long term with negative emissions. Whereas this more rapid transformation is driven by end-use measures, in particular, or heavily relying on granular, distributed, also supply-side options. So things like solar PV that are in principle modular, small scale, but mass manufactured, and therefore can be upscaled much quicker than large-scale options. I'll show you a few more figures later on. And then there is, to be honest, there is also negative emissions in the game here, but this is largely and afforestation measures, so quite conventional things that we have a lot of experience with, essentially returning land to nature. To make these global things that I've shown and will show a little bit more tangible, let me give you also a European perspective. What I mean here with Europe is essentially the EU 28, and then Norway, Switzerland, Iceland, and Liechtenstein, so the EFTA states and Turkey. This is how emissions have evolved over the last 26 years up to 2016. So we see a minus 16% reduction in energy and in industry-related CO2 emissions to get us more focused on the energy system side of things, which is a 9% reduction compared to 2010. And then this is the trajectory that this low energy demand scenario follows. For Europe, this would mean a 60% reduction relative to 1990. Let me remind you, there's a 40% in the NDC, there's a 40% reduction pledge by the European Union, and Norway has essentially adopted the same target in terms of total greenhouse gas emissions. This is energy-related CO2 only, which also in the 40% total greenhouse gas target would contribute generally more than 40%. But there is still a substantial gap between that pledge and the 60% that would need to be achieved in this context. So relative to 2010, it's minus 57%, and compared to current emissions, about halving emissions within 12 years. It's actually a little less. Right? We are already end of 2018. So one of the ideas of generating this a little bit alternative view was to look into emerging social and technological trends. So observables, including changing consumer preferences, such as changing diets. These are, of course, changes that are not necessarily happening from today until tomorrow, but rather with a new generation coming in, they may adopt different behavior or different preferences, like changing diets, but also a change in attitudes towards materialism, with a focus rather on services compared to ownership. So there is, for instance, evidence that that there is now, compared to 20 years ago, in many countries, fewer young people getting driver's licenses, but instead rely more on other services for generating their mobility. That, of course, also then goes along with different business models, such as the sharing economy, pervasive digitalization, and ICT convergence. I'll talk a little bit more about this later on. And then rapid innovation in granular technologies and service provision in a way. So one of these trends is moving from ownership towards usership. I mean, this is the service provision, car sharing, bike sharing, and all of these things that you are, I think, all familiar with. And one of the other features is the granular nature of technology that is here deployed. So not relying on lumpy, large unit size investment with high investment risk associated, such as nuclear power plants or large-scale airplanes, but rather relying on technology that can be mass manufactured and deployed much quicker. Mobile phones are, I think, one of the most equitable distributed resources in the world today. I think it has probably the best Gini coefficients, essentially of all things that I've seen being measured in that with that metric. So, other benefits is that there is empirical evidence that granular small-scale technologies learn much faster. In particular, and this is what has been done in this analysis or this figure, if you account for the contribution of, or if you separate out the contribution of economies of scale, so which in many other technologies contribute significantly to the learning. So in wind turbines, when you move from kilowatt scale to multi-megawatt scale, that is a contribution to learning because you can manufacture a larger unit, a larger wind turbine with not the same amount as multiple smaller wind turbines. And so if you correct for that, then you can see that small-scale devices, that would be here, those on the left-hand side, generally have higher learning rates. The equity benefits I already mentioned. What in this specific pathway has been looked at is also providing services to developing countries. I mentioned in the context of global mitigation, this is often a concern, that mitigation comes at the cost of development. So what has been explicitly looked at are decent standards of living that are supported, of course, also by provision of energy services. And here for four different types of services: food, thermal comfort, consumer goods, and mobility. What you see is the current level provided in the global north on a per capita basis, then the levels identified as decent living standards, and the development between essentially today and 2050 in the global south. So in many of these cases, the levels of service provision reach those that we have today in the global north. But in all cases, they substantially go beyond the decent living standards. I mentioned digital convergence as one important aspect that contributes to improved resource and energy efficiency. Smartphones that probably all of you carry with you integrate the services provided by some 40 devices if you go back a couple of decades. And that service provision is achieved at a much lower energy consumption, also taking into account embodied energy, standby energy use, and use in materials. One thing that we certainly can still do better, on is using these devices for a little longer than a year or two, which seems to be the average lifetime. And of course, then looking at recycling options. But generally speaking, this convergence can contribute substantially in terms of reducing energy demands. This is a decomposition of different contributions. So that on the one hand, the activity levels and the energy intensity in providing different services. The takeaway message here is for almost all of these, the activity levels, for all of these services, the activity levels go substantially up. So this is the story about providing more energy services, but energy intensity, and I think you see this most dramatically in particular here in this thermal comfort figure, are improved dramatically, so that in result, almost all of the green bars point downwards and leading to substantial energy savings. Here are a couple of examples at different levels, how this can be achieved. Of course, the challenges are very different in different sectors and in different countries. In some countries, in particular in developing countries, a lot of the infrastructure still is to be built, which of course offers a lot of opportunities to adopt best available technology. But in particular in Europe, we are dealing with a largely existing building stock with relatively slow turnover times. So things like standardized prefabricated thermal retrofits would need to play an important role here, and the Dutch example of Energiesprong is, I think in this case, a good one. Commercial buildings also face challenges, but there are these examples out there that can show how this can be done. In terms of how the energy system structure would need to evolve, here is the sectoral picture. In particular, buildings, that's the middle part, this bluish part, show a substantial reduction, but otherwise contributions come from all sectors, and therefore the sectoral structure essentially remains quite stable. But it's important to point out that despite substantially increased service provision, the final energy provided is about a third less compared to today. Today we are talking about 300 exajoules or more of final energy consumed at the global level, whereas this would lead us to around about 250 by mid-century. One of the key ingredients here is rapid electrification of services, and I think Norway is one of the countries that in particular in the transport sector has shown a way forward how this can be achieved. So that, relying heavily on electricity is one key towards improving efficiency, and enabling that transition is important, of course. And then that needs to be complemented by a rapid diffusion of low-carbon energy supply technologies, in particular renewables. But the challenge of doing that is, of course, much more modest if final energy demand is going down, because then the supply-side system just needs to provide much less energy. And then when coming to the characteristics of this transformation, I mentioned the faster electrification. In terms of absolute capacity additions for renewables and other low-carbon technologies, we actually wouldn't need to see much more than we have seen over the past few years, where we have witnessed remarkable upscaling of many of these technologies, if we manage to scale down the size of the energy system by focusing on demand-side measures. And then there are, of course, also, in particular, demand-side focused measures have shown in the literature to generate a lot of benefits with multiple sustainable development goals. And that will be the remaining 10 minutes of my presentation, essentially. Here's just a collection of policy measures. I don't want to go by any means through them in detail. I would like to point out that policy measures across these different domains that are pointed out here are addressing different actors, policymakers, service providers, but then also directly consumers, mayors of cities. So, and the scale at which these policies can be and should be enacted, also essentially crosses these scales. So it is important to see this as complementary measures to complement the global climate negotiations, but there is this action at all levels that can and would be needed to induce a transformation like this. So I will now look a bit more systematically at interactions between climate policy and sustainable development goals, in particular relying here on a study that has looked at targets related to 8 specific sustainable development goals. The study is focused on mitigation measures. So before I talk about that, let me also emphasize the main purpose of mitigation is, of course, reducing climate impacts, and also that in itself has implications across different sectors, and those sectors or impacts relate also to different SDGs, such as access to clean water, food security, and so on and so forth. What you see here is a metric of multi-sector exposure. I won't go into detail here. This is at 3 degrees, and if we switch to 2 degrees or 1.5 degrees, you can see that that the impact or the exposure in particular of vulnerable populations is much less in a 1.5 degree world compared to the 3 degree world. But this is just meant to be background for this graph, which I will spend a couple of minutes in explaining. And here the caveat is this doesn't include the impacts. So the benefits of reducing the impacts is not included here. This is more focusing on giving you an idea where potential trade-offs may emerge, so adverse side effects of climate policy that will need to be managed. And on the other hand, we of course also have significant benefits. In total, these are 20 different indicators. The coloring relates them to these 8 SDGs that I showed beforehand. To give you a better sense of what is shown, everything above the red 0 line indicates a risk for an adverse side effect. Everything below the red line is a potential co-benefit. What is plotted here is, this is a multi-model study, so there is some coverage of the uncertainty space here, so that's why you don't see just a single number. So what you see here is how a specific indicator, for example, here on the very left-hand side, we have biodiversity loss, changes in a 1.5 degree pathway in 2050 compared to essentially a current policy's extrapolation pathway. And you see the green bar here stretches from about 2 to 10, and this indicates that this biodiversity loss may increase 2-fold to 10-fold in 1.5 degree pathways. And this is specifically related to land use change induced by potentially large uptake of bioenergy as a measure. That doesn't mean that this has to happen in 1.5 degree pathways. It just indicates that there is a risk associated with that, and that risk should be managed. On the other side, on the right-hand side, you see, for instance, the renewable energy target under SDG 7, the energy SDG, and there we see a clear co-benefit, a roughly 2-fold to 6-fold increase in renewable energy deployment compared to a current policy's pathway. Let's look a little bit more systematically at this range of indicators. So for a set of indicators, we find robustly the risk for adverse effects materializing. Then there is an intermediate set of indicators where we see these bars stretch across the zero line. And that indicates that the direction depends really on the mitigation strategy that is implemented. Let me pick here water for energy as one example. In the electricity sector, a large fraction of energy use is related to cooling of thermal power plants. If you replace those by non-combustible renewables, such as wind and solar, which usually use much less water than current conventional thermal power plants, could be a co-benefit. If you do this mitigation in the power sector based on nuclear or carbon capture and storage, the situation might turn out to be the opposite. So really the devil's here in the detail, and again this highlights a point that needs, or an aspect that may need to be managed. And then for another set of indicators we find robustly co-benefits. Renewable energy I already mentioned, energy efficiency is among them, and then also air pollution and associated health impacts tend to benefit from stringent mitigation action. Also worthwhile pointing out that under the same SDG you can have different sub-targets, some of which show clear co-benefits, whereas others show adverse side effects. I was planning to go in detail, into a bit more detail here to show you potential trade-offs when it comes to access to clean cooking fuels. We'll probably skip that in the interest of time now, and summarize here with a picture on policy costs. On the one hand, you see here policy costs for climate mitigation, and again, this doesn't include the benefits of avoided climate impact. So it's just the additional costs as a fraction of GDP that would be associated with mitigation measures. And then we have a range of other targets here, such as energy access, which I've now not presented in detail, food security, so people being put at risk of hunger because of potential conflict over land between bioenergy and food production, or water for energy. I explained that a little bit. And what you see here, these smaller bars, are essentially estimates of complementary policies that would be needed to avoid adverse side effects. You can see that they tend to be significantly smaller than the mitigation cost estimates, but I think they are very essential for developing really towards a sustainable future, rather than focusing on climate mitigation at all costs in a way. That brings me to my concluding slides. We find significant co-benefits and adverse side effects of climate policies. This highlights the need for policy packages or a set of complementary policies that really foster achieving these multiple targets. Energy demand is really an interesting aspect, as it allows to maximize multiple benefits. And in addition, it allows accelerating the transformation, focusing on end-use measures and granularity. As an implication for policymakers, we really need a multi-actor approach, so policies at different scales, complementing each other. And on the business side, I would say, with a focus on more service-oriented business models, there's really also an opportunity in terms of deepening the value chains of businesses. So not just selling devices, but services instead. So with that, that's my only other Norwegian slide that I picked up along the course of this afternoon. Thank you.
Thank you, Volker. Would you like to go back to your final slide, please? Good. Thanks. So thank you for this sort of huge summing up of what we're actually dealing with. And I'm thinking, in your conclusion, there are some positives, some highlights as well. And as you're saying, there are some possibilities for the for business, for the industries, and so on. But I'm still thinking, to a certain extent, it probably boils all down to political leadership. How we're going from here, isn't it?
Yeah, I would definitely agree with that. I mean, there needs to be political will for this to happen, and one could, of course, say the challenge is so immense that it doesn't make really sense to follow this, because I mean, as you just saw, like 50% CO2 emission reductions within a dozen years sounds really super challenging.
It does.
I guess,
pretty unrealistic.
Yeah, I guess I shouldn't be here when if we sign up for this target, or I should be with you via video conference then as an alternative.
Yeah. Next time you will be, probably.
Sure. Always happy to do that.
But it's nice to meet in person as well. My point is, because earlier on today we've discussed several of these things, and as you mentioned, Jan Fuglestvedt made a presentation with a big overview of this. And I asked him about, the sense of urgency and how the IPCC doesn't want to sort of impose any political action on the different nations, and he rightfully answered that you shouldn't do that either, because it's up to the nations themselves what they want to do and what they can do. But are they fully understanding the sense of urgency that we're seeing now? Because the LED or the LED pathway that you showed, it's a pretty steep fall when it comes to reducing the climate gas emissions. And it has to happen very, very fast.
Yeah.
Are they getting it?
For sure. I mean, when I was reading through the press following the publication of the special report, how long ago is this now? A little bit more than a month, right? It sounded like the message was coming across, but it was equally stunning to see how quickly business as usual took over again. So essentially after a week, when the messaging was out, and there was some controversial discussions, and I had the feeling there was some sense of urgency. But following that, I think it pretty much got taken over by other business.
But hopefully this sense of urgency will come back in Poland in the beginning of December for the COP24.
Hopefully.
Hopefully. Are you going to be there?
Yes.
Good. Another thing that we discussed, and I saw that you had one slide showing to what extent the policymakers are responsible for changes to happen, but there was also consumers mentioned. And we discussed the consumers' role today. How big an impact do you think the consumers can have in the shift and the transformation that we need to do?
I mean, ultimately, consumers are not only consumers, but also voters, right?
Yes.
So ultimately, it's in their hands. And I think there are encouraging examples where diffusion is actually diffusion of technology, but also of behavioral change is happening maybe faster than anticipated. The big challenge is that this would need to happen at scale, really pervasively. And that's where I think there's a much bigger push needed. But it seems once some of these topics are gaining traction, that there are spillover effects.
And also the development of technology, which is moving quite fast, is probably helping a bit as well.
Sure. I mean, I think technology development as such isn't any faster than it has been in the past. But we have seen, a lot of examples where the diffusion then ended up being much faster. And as I mentioned, pervasive diffusion is really a key point here. That enables, and that needs to happen fast. In particular for the 1.5 degree target. Yeah.
There are a couple of questions from the audience. The first one is, can one expect a significant global market for CCS and bioenergy CCS, regardless of scenario?
Well, I mean, first of all, I should say this lead scenario was deliberately constructed to not use any carbon capture and storage as a communication tool. Whether this is realistic or not is a second question.
Yeah.
From my perspective, there is definitely a market for both. I think the focus on electricity generation and applying CCS there is probably not a good one. Because there are so many other examples of so many other technologies that have made a lot of progress compared to carbon capture and storage. But I think in particular the industrial sector and then also liquid fuel provision offers probably quite a few benefits. I mean, in this lead scenario, there is bioenergy and liquid biofuels are being used. For instance, to support aviation, where I don't think we have an off-the-shelf solution yet that can be deployed really rapidly. Biofuels there are attractive because they're compatible with existing supply-side infrastructure, with existing infrastructures. And of course, in that process, there is low-hanging fruits in terms of applying CCS in all of these processes. Even if you talk about first-generation ethanol production, right? Just the fermentation process releases carbon in relatively pure CO2 streams. And if you really are after the 1.5 or 2 degree target, it would be a shame releasing that CO2 into the atmosphere. I mean, and the technological challenge of capturing it and storing is relatively manageable from my perspective. So I think there will be sweet spots for carbon capture and storage, regardless of this lead scenario not making use of them. But there was, as I said, a deliberate choice.
And do you think that it would, do you envisage a market for this technology even in a 3 to 4 degrees scenario then? Or are we even not talking about such a degree scenario?
I mean, if there's lack of action, of course, that's a possibility. I mean, in some ways, we are also in the hands of the climate system because we don't know for sure how strong, even at very ambitious mitigation targets, how strong the reaction of the climate system is going to be. So I think there will also, if the world ends up agreeing on more moderate climate targets, also contributions will be needed from those sectors.
A final question: to what extent can Norway serve as battery by delivering balancing hydropower for the EU's growing wind and solar energy?
I mean,
we've discussed that earlier on today, you see.
Yeah, I wasn't able to follow that discussion. No. I have to admit. So I'm now at risk of saying something that has been extensively discussed and put aside for whatever reason. I think, but as you saw, I mean, many of the pathways foresee quite a significant upscaling of variable renewables, and managing that and integrating that into power systems remains to be a challenge. And for that reason, having a unique resource such as the Norway's hydropower resource is, of course, an interesting option. And then Norway has also probably more experience than any other or almost any other nation with applying carbon capture and storage. So there might also be space for hydrogen. So I think there are business opportunities out there in a world like this.
Definitely. So, Volker Krey, our time is running up. I'm very happy that you took the trip one day earlier, because I was told that you were supposed to come only for tomorrow, because you're going to be on the program tomorrow as well. But I'm very glad that you made the trip today and that we had the pleasure of listening to you and your presentation. So thank you once again, Volker Krey.
Thank you.